Hello, myself Pranita Paniji. I'm from CSE AI and ML. Let's discuss about the absorption, spontaneous, and stimulated emission about laser. Let's see what is the definition of laser. Definition of laser. A laser is a device that generates light by a process called stimulated emission. The acronym LASER stands for Light Amplification by Stimulated Emission of Radiation. Semiconductor lasers are multilayer semiconductor devices that generates a coherent beam of monochromatic light by laser action. A coherent beam results which all of the photons are in same phase. Let's see what is the operation of the laser. In 1985, Charles Townes and Arthur Squall theorized about a visible laser, an invention that would use infrared or visible spectrum of light. Here we see the laser means light amplification by stimulated emission of radiation. Let's see what is the basic idea of this laser. Now consider a group of atoms, exposed stream of photons, each with energy h mu. Let us assume two energy levels E1 and E2 of an atom. During transition from one energy state to another, the light is absorbed or emitted by the particles. Under this action, three processes can occur. They are stimulated absorption, spontaneous emission, and stimulated emission. Let's briefly discuss about each of these processes. Absorption. Let's see what is meant by absorption. Absorption is a process in which optical energy is converted to an internal energy of electrons, atoms, or molecules. When a photon is absorbed, the energy may cause an electron in an atom to go from a lower to a higher energy level, thereby changing the internal momentum of the electrons and the electrons' internal quantum numbers. Let's discuss absorption through a diagrammatic representation. Here we see in the figure if a photon of energy h mu, that is E2 minus E1, collides with an atom present in the ground state of energy E1, then the atom completely absorbs the incident photon and makes the incident photon transition to excited state E2. So this is called the absorption. Now let's see what is meant by spontaneous emission. Spontaneous emission is an energy conversion process in which an excited electron or molecule decays to an available low energy level and in a process gives off a photon. This process occurs naturally and does not involve interaction of other photons. The average time for decay by spontaneous emission is called the spontaneous emission lifetime. Let's understand this spontaneous emission by the diagrammatic representation. In this figure, we can see that an atom initially is present in the excited state that, that makes transition voluntarily on its own without any aid of external stimulus or an agency to the ground state and emits a photon of energy h mu, that is E2 minus E1. This is called the spontaneous emission. These are incoherent in nature. Let's see what is meant by stimulated emission. Stimulated emission is a process in which an excited electron or molecule interacts with a photon, decays to an available lower energy level, and in the process gives out a photon. As with other processes, this process can occur in isolated atoms, ionic compounds, organic molecules, and other types of materials, and it can occur in solids, liquids, and gases. Let's see the diagrammatic representation of the stimulated emission. So, in this figure, we can see that a photon or having energy h mu, that is E2 minus E1, impinges on an atom present in the excited state and the atom is stimulated to make transition to the ground state and gives off a photon of energy h mu. The emitted photon is in phase with the incident photon. That means the two photons are coherent. This type of emission is known as the stimulated emission. Let's see what is meant by stimulated emission. So this diagram represents the stimulated emission in which the incident photon and the absorbed photon have same are coherent in same phase. These are the absorption, spontaneous emission, and stimulated emission. The first diagram shows the absorption, and the second diagram shows the spontaneous emission, and the third diagram shows the stimulated emission. Putting it all together, assume that we have a two system in equilibrium, the black body radiation field. So then when we have two systems, the first diagram represents the absorption, that is, the atom excites from a lower energy state to higher energy state, whereas in spontaneous emission, it voluntarily de-excited from higher energy level to lower energy level state, whereas in stimulated emission, the photons are incoherent. Let's see the difference between spontaneous and stimulated absorption. Spontaneous emission. The atom in the excited state returns to the ground state, thereby emitting a photon without any external inducement. Whereas in stimulated emission, an atom in the excited state is in to return to ground state, thereby resulting in two photons of same frequency and energy. In spontaneous emission, the emitted photons can move randomly, whereas in stimulated emission, the emitted photon move in same direction and is highly directional. In spontaneous emission, the photons are not in phase, whereas in stimulated emission, the photons are in phase. In spontaneous emission, the rate of transition is given by A1 into N2, whereas in stimulated emission, the rate of transition is given by B21 into N2 into rho. In spontaneous emission, the photons are incoherent, whereas in stimulated emissions, the photons are incoherent in nature. In spontaneous emission, uh, they have more angular spread during propagation, whereas in stimulated emission, they have less angular spread during the propagation. Example for spontaneous emission are light from sodium or mercury vapor lamp, whereas stimulated emission are light from laser source. Thank you.